If Hubble can make photos of galaxies 13.2 light-years away, is it ever going to be possible to look back 13.8 light-years away and see the Big Bang? Can I add to this? Can we see 13.2 light-years away in every direction? Or do you have to point a certain direction to see that far? Is there an edge we can see if we look in any particular direction? Are we just sitting in the center of what we can see, or have we been traveling from a point that we understand to be the center of the Big Bang? The cosmic background radiation is what is left of the Big Bang. Since the universe is expanding at an increasing rate, light from far away, also from a long time ago due to light speed, has become redshifted, lowering of the frequency of light, to the point that it is not visible light, but rather microwave light, which is what the cosmic background radiation is. We can already look back and see the Big Bang, sort of. There is this thing called cosmic background radiation, which is radiation left over from the early universe shortly after the Big Bang. It is uniform whichever direction you look. So no, we can't look back and see visible light from the Big Bang, but we can see it in other parts of the electromagnetic spectrum. Additional question: what does space look like when we get that close? Since there was a super fast expansion around that time period, wouldn't it be the case that as we look further away, the universe gets smaller? What kind of distortion does that cause? Single quote closing square bracket. It's not a perfect answer, but I'm surprised to see no one has mentioned the cosmic microwave background. It's really as far back as we can see. It's the first time the universe became opaque. It has been redshifted so much it is in the microwave range. Semi-related question: what happens to the photons emitted from the Big Bang? Wouldn't they be the boundary of the universe, perpetually penetrating new, empty space? And if the universe can really contract, does that mean that those early photons are just being pulled back to center by gravity? Dude, 13.8 light-years is only 13.8 years. I think you mean 13.8 billion light-years. Right now I believe our limit is *** 13.2 billion light-years **, which leaves about 600 million for the formation of the first hydrogen atoms formed from the subatomic and quantum particles as they cooled after the Big Bang. Light was sort of trapped in the first 300k years of the existence, and light didn't even exist for a few seconds after the Big Bang. I mean, it's odd even trying to define that, as time didn't exist for some time after the Big Bang. Lol. In relation to the OP's question and some of the very interesting responses, if we eventually build a big telescope on the moon, which has almost no atmosphere, as I understand it, so the telescope will have a big advantage over those on Earth, what will we be able to see that we can't see now? I think it's worth adding that photons from the time of the Big Bang would actually have traveled more like 20 billion light-years in this time, because spacetime has been stretching. This is why the cosmic microwave background is in the microwave range, because the wavelength of the photons gets stretched too. Quote closing square bracket. That's the observable universe. We don't know if the Big Bang is actually that far or after 13 billion years away. Another Hubble is seeing another 13 billion years, that another Hubble is seeing another 13 billion years. Thought this was relative. The expansion of the universe is faster than the speed of light, so we will only be able to see a portion of the known universe. Because we can only see what light reaches to us and can't see beyond that point. No. Unfortunately, light was not formed and transferred through the universe until hundreds of thousands of years after it cooled down. We'll need to observe it with something other than electromagnetic radiation. Oh, I was confused. I read the post, and the op says there are galaxies 13.2 light-years away. Hell, there are something like 28 star systems within 13.2 light-years of us. Very well within this galaxy. The Andromeda galaxy is 2.5 million light-years away. Then I realized he must have meant 13.2 billion light-years. Single quote closing square bracket. The moment the Big Bang happened, the light from it started traveling at the speed of light. All matter and energy in existence, including us, traveled out, but we, the matter, can't overtake the light, wait 13.8 billion years, and then turn back to see the light. We are the energy, matter from the Big Bang. We can't turn back and see ourselves. Nope, early universe is opaque, best you can do is CMB. Also, things in the universe are all moving away from each other, with the furthest objects moving away the fastest. There is a point where the amount of space between us and some distant object is expanding faster than light can travel, thus making it impossible to see. At least impossible as far as we currently know. Imagine some equation about the conditions of light or echoes of the Big Bang proves incontrovertibly that the universe basically has to be absolutely infinite. To me, an interesting question is, what does that mean? I know maybe this belongs on a philosophy or cosmology list. As others have mentioned, there is a limit for visible light. We can actually theoretically see further back in time using neutrinos instead of light, but there is a limit for this as well. Also, these neutrinos are incredibly low in energy and so far undetected. I'm hopeful for something happening in my lifetime, but it could be longer.